Okay, so as promised, we are going to cover control nets today. And I do have to say, I think you'd be hard pressed to find a better control net workflow out there. This thing is cleaner than a... Let's take a look at the workflow and then we'll talk about how to get it installed, and then we'll cover some examples. This bottom row here is nearly identical to the standard Flux workflow, and then we just have this one extra group up top that has our control net nodes. And we're going to start on the left and work our way to the right. The first thing we have is our input image that is being fed into this anything everywhere node. I haven't covered anything everywhere in a video of its own, which I will do, but it's pretty self-explanatory, so let's just take a look at what it does. The way anything everywhere works is you feed some type of input into it. It will recognize what that input is. In this case, it's an image. And then anywhere in your workflow where there is an image input that does not have a pipeline going to it, that image will get fed to it. So for example, you can see our input image going to our anything everywhere node, and then these three nodes here all have image inputs that have no pipelines going to them. So this image will be fed to all three of these nodes. It's also fed to the fourth input of our input switch. We won't actually be using that. The only reason I have a four-way switch here is because there was no three-way switch to choose from. So we have a four-way switch with a fourth input that we're just not going to use. Similarly, our VAE is going to an anything everywhere node because that needs to, of course, go to our decode node as usual, but it also needs to go to our apply control net node. So rather than running a noodle from here to there and from there all the way down to there, looked a little messy, so I went ahead and put it into this anything everywhere node. And now anywhere in the workflow where there is a VAE input that does not have a pipeline going to it, this will go to that, which of course is only to these two places, but again, it just looks very clean to do it this way. And the last use everywhere node that we have is with our positive and negative prompts here. This node is specifically for text prompts, and the top is for the positive and the bottom is for the negative. And these just go up to our apply control net node. The other option was just to run pipelines from here all the way up to here, but it looked a little bit messy, so this makes everything much cleaner. Now, of course, Flux does not use a negative prompt, so we simply have an empty text field here, and the only reason we have that is because the apply control net node does in fact require a negative prompt to be fed into it, or else the workflow will not run. So that is the only point of having a negative prompt in here. Back to our control net group, we have our input image. It's going to our anything everywhere node. That will go to one of these three nodes, and these three nodes are image preprocessors, which will do a little bit of preprocessing before it gets passed to our apply control net node. So based on the type of control net we want to use, we will want to use one of these three preprocessors, and we can simply use this switch to choose which one we want, like so. So for example, if we wanted to use the Canny control net, we would just select it in our load control net node and then make sure our switch is on 1, which would be this Canny preprocessor. The input image will go through the Canny preprocessor, and then it will be fed out to this preview node where we can see the effects of the Canny preprocessor, as well as to our apply control net node, which will then go on to our sampler. Similarly, if we want to use the Flux HED control net, we would simply select that one and then make sure our switch is on input 2, which is being fed the image that is being preprocessed by our HED preprocessor. And again, that will get fed out to the preview image where you can see the effects of the HED preprocessor, as well as to our apply control net node, which of course then will go back down to our sampler. And finally, if we wanted to use the depth control net, we would simply select that and turn our switch to 3 so that we get the output from the depth anything preprocessor fed into here, which again would get fed to our preview image node as well as to our apply control net node. So given all of the nodes that need to be packed into this group, I think it is cleaned up very very nicely. All you got to do is select the control net model you want to use and then change your switch to whichever of the preprocessors corresponds to the control net that you're using. And that's all there is to it. Now, aside from being ridiculously clean, there are some key differences between this workflow and other XLabs control net workflows, primarily being that I am not using the XLabs nodes to load and apply the XLabs control net models. And the reason for that is if you use the XLabs load control net node, then you have to use the XLabs apply control net node, which means you also have to use the XLabs sampler, and therein lies the problem. We do not like the XLabs sampler. There are many problems with it. Now, to be clear, the XLabs sampler works pretty well for what it is. However, there are 3 problems with it that make it unsuitable for me. The first thing being that you do not get your choice of sampling and scheduling algorithms on the XLabs sampler. I have no clue what sampler and scheduler they're using, but whatever it is, you're stuck with it, which means however your output image turns out, it is what it is. You can't change it. And I guess I'll just go ahead and show you right here. So you can see that there is no choice of sampler or scheduler on the XLabs sampler. The only thing you get control over is your seed, number of steps, your CFG, and your image to image strength, which is a fair amount of control, but I think having control over the sampling and scheduling algorithms is pretty critical. I have no clue why they didn't put that in here, but that's a deal breaker for me. Secondly, as we saw in our testing video, and if you haven't watched that, it is very important. Make sure to watch it. It'll be like right here somewhere, and I'll also leave a link in the description. Anyways, we saw that the Flux sampler parameters in conjunction with our plot sampler parameters node creates a very powerful testing workflow that I just didn't want to give up. Being able to generate a huge batch of images with different samplers and schedulers and all different kinds of combinations of these values is really important to me so that I can generate a whole bunch of images at once and then just pick the one I like. Rather than just doing a whole bunch of runs and tweaking all of these settings in between each run, I can just select a whole bunch of things on this sampler, click the Q button once, and then generate a massive batch of images. And again, if you haven't seen that testing video, do check it out. It is very important. And then the last problem with the XLabs sampler, which is more of a minor detail, but I just don't like it, is that unlike on our Flux sampler parameters, where we have the max shift and base shift built in, that is not built into the XLabs sampler. So you would need this extra model sampling flux here if you wanted to use this sampler, since these parameters are not built in to the sampler itself, which just creates an extra node off to the side. Again, that's not a huge deal, but I just don't like it. This is much cleaner. So to recap, we are not using the XLabs sampler because it does not give you control over the sampling and scheduling algorithms. It is not compatible with our plot sampler parameters, which allows for our powerful testing workflow, and it creates the need to have our extra model sampling flux node off to the side, which just adds a little bit more clutter. So for those 3 reasons, we are not using the XLabs sampler, which means we cannot use their apply control net node either, because that node requires you to use the XLabs sampler. We are using the XLabs control net models. We're just not using their supplied nodes to load and apply the control net in our workflow. All right, I think that about covers it. Let's take a look at how to get it installed. As usual, I have made installation a breeze for you guys. All you got to do is jump over to the Patreon page and scroll down. Right now, it's the latest activity, but if you don't see it there, keep going until you see this mad scientist right here who is conducting some type of dangerous experiment. We are just going to click on him, open in a new tab, drag him on off to the side, back to our comfy, drag him in, hit up our manager, install missing custom nodes, give our comfy a restart, and you are set. I believe this depth anything node should come with one of these pre-processing models, but if it does not happen to come with these, all you got to do is jump into your manager, go to your model manager, and search for depth anything and install one of these models, and you will be able to use it with your depth anything node. And then the only other thing we need is our control net models. And to get those, of course, we are going to head over to XLab's control net collections page here. We just need to go over to the files and versions and then download these three here. Now you can see they have several versions of each. I just went ahead and grabbed the V3 because it's the latest one, so why not go ahead and use the V3 instead of the older ones. You'll just right click on that, save link as, and then you're going to save that into Comfy Models in Control Nets. If we were using their node to load the control net, that would go under Comfy Models into XLabs and then in Control Nets. But since we're not using their node, we want to put that in our standard control net under Comfy Models Control Net right there. And then that way our load control net node can find them. So this is where you're going to want to save them, which again is different from probably other workflows that you may see on the internet. So just wanted to clarify that so you're not confused. So anyways, you'll save them right there. Another thing to note really quickly, I'm mentioning this in all of my recent videos, is that you'll see I have renamed all of my files, not only in my control net, but also in my checkpoints, in my clip vision, VAE, all of my safe tensor files. I've gone through all of the folders and have renamed them to .sft rather than the standard .safe tensors. So whenever you pull my workflows into your Comfy, you may get a whole bunch of red boxes around all of your nodes because, for example, the clip loader you can see is .sft, the VAE is SFT, my NF4 and my dev model SFT. So if all of your model files are named .safe tensors, you're going to see red boxes on everything. This just allows me to make my nodes a little bit skinnier, which just tightens up the whole workflow just a little bit more, and I think it looks neater. If you're an OCD freak like me, you can jump into your Comfy folders and rename all of your model files to .sft instead of .safe tensors. If you don't want to do all that, whenever you pull the workflow in and you get all your little red boxes, just come to your drop down menu and select your NF4 .safe tensors, and obviously everything will work. It's just going to say .sft because you're pulling my workflow in and my workflow has .sft. So quick side note, but important, and I'm mentioning it in all of my recent videos because I want to make sure the whole crowd hears it. That way you don't freak out whenever you see a bunch of little red boxes around all of your nodes. So we've pulled our workflow in, we've installed our missing custom nodes. If you needed to get this depth anything model, we got that through the model manager, and then we've got our control net models from XLab's Hugging Face page. The only thing you need to do now is click your little refresh button down at the bottom, and you should see the models in your drop down menu. So without further ado, let's take a look at some examples. Let's bring in our Nordic woman from the IP adapter video. First, let's try out our Canny control net. The Canny and the HED control nets work off of edges. So the Canny and HED preprocessors are going to extract the edges from your image just in slightly different ways, and you'll see what I mean in just a second. On the Canny preprocessor node, we have a value for low threshold and for high threshold. This is going to allow you to tweak the amount of edges that are extracted from your image. In order to take a look at that, let's first bypass everything in the workflow except for our Canny preprocessor. So with these values for our low and high threshold, when we hit the Q button, you can see it has extracted nearly every edge possible from this image. Whenever I first started using this, I was thinking that if I set the low threshold to the lowest possible value and the high threshold to the highest possible value, that would give me the most edges possible from the image. However, that is not how it works. Whenever we set the high threshold to 0.99, which is the highest value you can put into this field, we get basically no edges out of this image. Since that was confusing for me, I asked our dear friend to explain how this works, and you can see there is a nice long answer here, and at the bottom I told it what my intuition was about this and asked it to summarize why my intuition was incorrect. And you can see the answer here: setting both thresholds to the lowest possible value detects the most edges because the algorithm considers nearly all intensity changes, even weak ones. When you set the low threshold low and the high threshold high, only very strong edges, aka way those above the high threshold are detected, and weak edges are discarded unless they are connected to a strong edge. This wide threshold range causes fewer edges to be detected, as most weak edges don't meet the high threshold or aren't connected to stronger ones. Essentially, a larger gap between the thresholds filters out more edges, leaving only the most prominent ones. And when I read that, I said, okay, that makes sense. So if you want to tune your preprocessor to get fewer edges, then you will want to have a wider gap in your low and high threshold like we have here. And if you want more edges to be detected in your input image, you will want to narrow that gap. That's exactly what I want. So I will set those back to the lowest value, which means I will be detecting as much of the edges as possible. And again, you can see the effect that that has right here. So let's reactivate the rest of the workflow and give this a try. Over on the apply control net, we have 3 fields, one for the strength, one for the start percent, and one for the end percent. And the percentage is not the percentage of strength, it's the percentage of the generation process. So for the start percent, we have this set to 0 so that our control net starts being applied at 0%, aka on step 1, and the end percent set to 1, which is 100%. So basically what this is saying is apply the control net from start to finish. If you wanted to apply the control net only during the first half of the generation process, you would set that to 0.5. So that would go from 0% to 50%. If you wanted to apply it only on the last half of the image generation process, you would set that to 0.5 and that to 1. And so your control net would only start being applied at 50% through the image generation process. So if you're taking 24 steps, this would start being applied on step number 13. But I want it to be applied the whole way through, so I will set that back to 0. And so now we have a strength of 0.5 on our control net, and it will be applied to every step in the generation process. Now, finally, we need a prompt. We have the beautiful Disney princess with long blonde messy hair, blue eyes, hands in her pockets in a candlelit kitchen with a bright window, foggy forest, very expensive stuff, 8K realistic masterpiece. What we're attempting to do here is to recreate this exact image styled as a Disney princess. Let's actually start this at 0.1 and see how that goes. Oh, bigger.
Whoa! This makes things smaller.
No, bigger.
Oh, bigger.
And here are our results. As you can see, of course, we have our Disney princess, and she has a very similar facial structure, very similar long blonde wavy hair in a very similar environment. The counter running down the side behind her, stove over to the right, window over to the left with the foggy forest, and some cabinets up above with a stove hood right there. So at point 1, this is already applying the environment that our woman is in, as well as the facial features and the wavy hair very effectively. So let's step the strength up progressively and see what kind of results we get. Going to point 2, we can see that not only the woman, but also the surrounding environment is starting to look a lot more like our input image. For one, the stove hood here looks much more like the stove hood we have over here. And as we can see, the facial structure is looking a lot more like our woman in the input image, and the hair is starting to develop these dark streaks like the woman in our input image has, rather than being a platinum blonde hair as in the previous image. Going to 0.3, now we have our second candlestick over here in the window, so starting to match that very much indeed. And again, our woman is starting to look much more like the facial structure of the woman in our input image, and again, the hood is becoming more pronounced as it is over here. So let's bump this up to 0.4 and see what that gives us. Again, the facial structure is matching a little more closely. The darker streaks are developing more in the hair, and the hood is becoming more pronounced here. 0.5. The shelving is becoming more pronounced there. A little more darker streaks in the hair. The texture of the top of her dress is starting to match the texture of this woman's top. Also, she's now wearing long sleeves, and the sink is starting to get a little bit smaller over over here like it is in the input image. Bumping this up to 0.6, and now we have open shelving here in the back as we do over here, and I'm starting to see more and more dark streaks coming into the hair like our woman on the left. Also, the waviness and length and overall style of the hair is starting to match the woman on the input image very closely as well. Jumping to 0.7, wow, and we see here that now our Disney princess is wearing not really a dress, it looks like some sort of top that is very similar to the top that the woman on the input image is wearing. Also, the size of her breasts is much less pronounced, we'll say, than it was previously. So this is starting to look very much like our woman in the input image indeed. Jumping up to 0.8, very interesting. So the shelving is matching very closely. There is a lot of stuff on the shelving that's not exactly similar to what's over here, but the shelving itself is matching very closely. The stove hood is also nearly identical to what it is in the input image, and we have this cutting board over here in the input image, and that looks like it's forming into some kind of square shape there. It's not a cutting board. A lot more darkness in her hair, and of course we can see now she is wearing some kind of top that is tucked into whatever this is on the bottom. Jumping to 0.9, and above 0.8, 0.9, things start to get a little wonky. We're going to start seeing weirder and weirder results as we get higher and higher, but let's go ahead and just try to jump this up to 0.95 and see what we get. Yeah, so this is looking very weird indeed. Obviously you don't want to apply the effect with too much strength, so I think in this case 0.5 is a good strength to apply. We have the woman who looks very much like the woman on the input image. The surrounding environment is nearly identical. The texture of her top, the coloring and style of her hair is nearly identical to what we have in their input image, but we still retain that Disney princess vibe. The HED and the depth control net models are two additional ways of achieving the same result. So let's just take a look at a couple of examples and see how those compare. Let's do our HED first. We will select our HED control net and we will switch our input to number 2. Bypassing the rest of our model, we can see the HED preprocessor also extracts edges from the image, but in a slightly different way. I won't read through all of this, but if you want to know, you can pause the video and read this if you like. If we turn this safety from disable to enable, it effectively kind of denoises this image. There is a little more softness, a little more contouring going on when we have this set to disable as opposed to when we put it to enable. The edges are a little more rigidly defined. So let's set this to disable so we have nice soft edges and contours. Bring the rest of our workflow back into the mix and try this at a strength of 0.5. The image is much softer. The HED control net compared to the Canny control net at the same strength level tends to do a better job at recreating the image just with a kind of softer feel. So if we open this in a new tab and compare the two images, on the right we have the Canny at 0.5 and on the left we have the HED at strength 0.5. Much more of the details of the HED control net is more accurate. So for example, we have the shelving that matches our input image very similarly, the hood, the cutting board in the background, 2 skinny candles, 1 fat candle with the plant in between, this little mat that is setting beside the sink here. All of these details are nearly identical to what they are in the input image, but the overall image has this kind of smoother, softer texture to it. And then finally, we will just compare this to the depth control net at a strength of 0.5 as well. So we will select our depth model, set our selector to number 3 so that we get the output from the depth preprocessor and run that again at a strength of 0.5. And you can see the depth map here. Very nice. And here is the result. And in this particular case, I think the depth control net is the clear winner. For one, we have the woman looking directly at us, whereas in the Canny and HED control nets, the woman is looking kind of off to the side here, but in the original input image, the woman was looking directly at us as she is here in the depth control net output. Also, since the depth preprocessor does not extract edges from the image, the details such as the texture of her hair or of her skin or of the top that she's wearing are filled in by the generated Disney princess image, which just produces a cleaner look as it's not trying to merge those details with the original input image. On the Canny image on the right here, we have a similar texture to the top that the woman in the input image is wearing, but since it's trying to merge that with the generated Disney princess image, the effect is that it's kind of blurry, whereas over here the texture of her top is much sharper. And you'll notice the same effect on her skin, in her hair, as well as in her eyes and the details of her lips. All of this stuff is much sharper and clearer in the depth control net output because it's not trying to merge those details with the details from the input image. As we saw in the depth map that was produced, all of those details are kind of blank, and so it is able to recreate the image, including the subject and the surrounding environment. But since the textures are not included in this depth map, the generated image is able to apply those effects over these blank areas, which again just results in a sharper, more detailed output image. Of course, that's not to say that the depth control net is always going to be superior. In some cases, the depth control net is going to win out, and in some cases, the HED or the Canny control net will win out, and that's just going to be dependent on the particular situation that you have. So that was a lot to cover. I think that is quite enough for this video. My next couple of videos are going to be diving deeper into the IP adapter and control nets. I hope you guys found this helpful. I really enjoy the control nets and the IP adapter specifically. It is proving to be quite flexible and quite powerful, so I'm having a lot of fun with that. I hope you guys come up with some cool stuff too. If you end up producing some really cool results, be sure to leave that stuff in the comments, or you can always email me or tag me on X. If you found the video helpful, be sure to give it a like, make sure you're subscribed if you're not already, and share this with anyone you know who might find it useful as well. And now it's time for me to get some breakfast and an energy drink and get to editing. So I will see you guys on the next one. Take care.